Welcome to Educator.com. In today's lesson, we'll be covering linear equations. Again, this is some review from Algebra 1, which we'll discuss here, and if you need further detail, go back to the Algebra 1 lectures and check those out for this subject. So a linear equation is an equation of the form ax plus by equals c, where a, b, and c are constants. For example, 2x plus 5y equals 3, and here a equals 2, b equals 5, and c equals 3. Another example could be x minus 7y equals 4. Here, even though it's not written, there actually is a 1 in front of the x. Just by convention, we don't write it out when the coefficient is 1. So a equals 1, b equals negative 7, and c equals 4. We'll talk a little bit more about what this form is. A linear equation represents a function which is known as a linear function, and that can be written in the form f of x equals mx plus b. And this is a very useful form of the equation that will be discussed in another segment. And an example of this would be something such as f of x equals 4x plus 2. You may also see it written as y equals 4x plus 2. And here, m equals 4, b equals 2. And these two numbers represent certain elements that we'll talk about in a few minutes. Okay, so the first form of the linear equation that we talked about just a minute ago is also called standard form. So a linear equation is in standard form if it's written in the form ax plus by equals c, where a, b, and c are integer constants. And this is important, with no common factor. If a common factor remains, it's not in standard form. For example, if I have an equation 9x plus 4y equals 10, this is in standard form. I have ax, so 9 is a, plus by, b is 4, equals c. c is 10, and there's no common factor. So consider another possible equation. 6x plus 8y equals 12. This is not in standard form because 6, 8, and 12 have a common factor. What I need to do is divide both sides of this equation by 2 to get 3x. So divide by 2, both sides of the equation by 2 to get 3x plus 4y equals 6. Now it's in standard form. Another example would be if I had 7y plus 5 equals negative x. Again, not in standard form. I can add x to both sides to get x plus 7y plus 5 equals 0, and then subtract both sides, subtract 5 from both sides to get x plus 7y equals negative 5. So this is standard form. Okay. We can graph linear equations using the intercept method. Recall that the point where a line crosses the x-axis is its x-intercept. And the point where the graph crosses the y-axis is the y-intercept. For example, if I had a line such as this, first the x-intercept is right here. X-intercept is negative 2. And at the x-intercept, y is always going to be 0. So the coordinate pair would be negative 2, 0. Because it crosses the x-axis, and so y is 0. The y-intercept right here y equals 4. And at this point, x is going to equal 0. So 0, 4 is the y-intercept. And we can use this knowledge in order to graph a linear equation. For example, if I have a linear equation, 2x plus 3y equals 6, all I need in order to plot this are 2 points on the line. Now, I can easily get 2 points by finding the x and y intercepts. So I know that with the y-intercept, x will be 0. So if I let x equal 0, that's going to give me 0 times 2 is 0. So that will be 3y equals 6. 6 divided by 3, y equals 2. Okay, to find my second point, I'm going to find the y-intercept. So this is actually the x-intercept right here. 0. Okay, so when this is the y-intercept. Y-intercept right here. Now, I'm looking for the x-intercept. The x-intercept is the point at which y equals 0 and the line of the graph crosses the x-axis. So this time, I'm going to let y equals 0. So I'm going to have 2x plus 3 times 0 equals 6. Or 2x plus 0 equals 6. So then I end up with x equals 3. So this is the x-intercept. Now I have 2 points. I can plot the line. So y-intercept, x is 0, y is 2. Y-intercept is right here at 0, 2. The x-intercept is right here at 3, 0. Now I've got 2 points, and when I have 2 points, that means I can connect them to form a line. And I did that by finding my x-intercept at 3, 0, and my y-intercept at 0, 2. So the technique is to find the x and y intercepts by letting x equal 0 and putting that into the equation and solving for y to get the y-intercept, and letting y equals 0 to find the x-intercept, and then using those 2 points to plot the line. In the first example, is the function linear? Well, recall that a linear function can be written in standard form, and standard form is ax plus by equals c. So I look at what I have here, and I have ax, so it seems like I'm going along okay, plus minus by, or that would be the same as plus negative by, so that's fine, equals c. But then I've got this over here, and this is not part of standard form. And you could attempt to get rid of that. Maybe you're like, okay, I'll multiply both sides by x to get rid of it, but then see what happens. All right, so let's see what happens if I try to multiply both sides by x to get rid of this x in the denominator. Okay, I end up with 2x squared minus 3xy equals 4x plus 1. So I'm no better off. I still don't have it in standard form. There's no way for me to get this in standard form. Therefore, this is not a linear function. So not a linear function. It's not in standard form. I can't get it into standard form. Okay, is this function linear? Well, recall that we talked earlier about the form g of x equals mx plus b. And remember, g of x, that's the same idea as f of x. G of x, you can use different letters. So it's still just, we're looking for this form. Okay? For a linear function. Well, I'm looking at this, and I've got what looks like an mx and a b, but the problem is I also have this. And this is not part of the form for a linear function, this x squared term. Therefore, this is not a linear function. once again, I can't get it into the right form for a linear function. Okay, in example 3, we're asked to write the equation in standard form. And recall that standard form is ax plus by equals c. And I'm dealing with some fractions, and I need to get rid of those in order to get this in standard form. So I can do that by multiplying first both sides of the equation by 3. This is going to give me 3y over 6 equals, here the 3's will cancel out, negative 7 times 3, that's negative 21. I can simplify this to y over 2 equals x minus 21. So I'm still left with a fraction. I'm going to multiply both sides of the equation by 2 to eliminate that fraction. 2's cancel out, so I have y equals 2x. Negative 21 times 2, that's negative 42. Next, I'm going to subtract 2x from both sides to get this, the x on the left side of the equation. And just switching around the order of the x and y to match this, negative 2x plus y equals negative 42. And you could stop here, or you could multiply both sides by negative 1, and that's more conventional to have the a term be positive. So that's going to leave me with 2x minus y equals 42. So I started out with this equation, and I wanted to get into this form. And I could achieve that by first multiplying by 3 to get rid of this fraction. Then multiplying, I ended up with this, multiplying by 2 to get rid of the y fraction. Then simply subtracting 2x from both sides to get the 2x on the left, the ax on the left side of the equation. And finally, just a little more work to clean this up, multiplying both sides by negative 1. So this is the equation in standard form, where a equals 2, b equals negative 1, and c equals 42. Example 4. Find the intercepts and graph the equation 4x minus 5y equals 20. So we already talked about how with the x and y intercepts, you can find those, and then you'll have 2 points, and you can graph an equation. So first, in order to find the y-intercept, I'm going to let x equal 0. So this will give me the y-intercept, the point at which the line crosses the y-axis. So to find the y-intercept, I'm going to substitute 0 for x. So this is going to give me 0 minus 5y equals 20, or negative 5y equals 20. Divide both sides by negative 5 to get y equals negative 4. Okay, next I want to find the x-intercept. To find that, I'm going to let y equal 0. So I'm going to go back and do this again, this time letting y equal 0. So this is for the y-intercept, and this is for the x-intercept. So this is going to give me 4x minus 0 equals 20, or 4x equals 20, which is x equals 5. Now that I have my x and y intercepts, I actually have 2 points on the line. So my first point is 0, negative 4, y-intercept. My second point is at 5, 0. And that's the x-intercept. Okay. Connecting these 2 points gives me the graph of this equation. So we use the intercept method in order to graph, finding the x and y intercepts, plotting those out on the coordinate plane, and then using those to form a line. That concludes this lesson for Educator.com, and I'll see you here again soon.